the ocean had always been a defense. For centuries, water protected empires. It slowed armies. It separated continents. It punished mistakes without mercy. But by 1941, the United States faced a brutal truth. To win the most destructive war in human history, the ocean could no longer be crossed. It had to be defeated. Before World War II, amphibious invasion was not a science. It was a gamble. Military academies studied land warfare and naval combat as separate disciplines. Armies marched. Navies sailed. What happened between ship and shore was rarely discussed, because it almost always ended in disaster. The most infamous example was Gallipoli in 1915. British and Allied forces attempted to land troops on a defended coastline. The result was catastrophic. Landing boats stalled. Men were slaughtered before reaching land. Supplies piled up offshore. Command collapsed. Gallipoli became a warning, burned into military memory. A fortified beach could not be taken. By the 1930s, most generals believed this problem was unsolvable. World War II shattered old assumptions. Germany conquered Europe using speed and coordination. Japan expanded across the Pacific with island-hopping strikes. Both Axis powers relied on a simple advantage. They were surrounded by water. If the Allies wanted to fight back, they could not march across borders. They had to land. Not once, not twice, but dozens of times across thousands of miles under fire. And unlike Gallipoli, failure was not an option. Consider what an amphibious landing actually requires. Not in theory, in reality. You must transport tens of thousands of men across open ocean. Carry tanks, artillery, trucks, fuel, food, and ammunition. Land them on beaches with unknown terrain. Do it under machine gun fire, artillery fire, and air attack. Keep supplying them every hour afterward. If any part fails, the invasion collapses. No army in history had ever solved this equation. When the U.S. entered World War II after Pearl Harbor, it was not prepared for amphibious warfare. America had battleships. America had aircraft carriers. America had industrial power. But America lacked something far more important: experience. Its military doctrine was defensive. Its landing equipment was outdated. Its understanding of beach assault was theoretical. The U.S. Marine Corps had experimented with amphibious concepts, but on paper, not under fire. Now theory was no longer enough. The sea is not empty space. It destroys machines. Salt corrodes metal. Waves crush hulls. Currents scatter formations. Storms erase planning. Then there is the shoreline, the most dangerous zone of all. Shallow water grounds ships. Hidden reefs rip open hulls. Soft sand swallows vehicles. Tides expose or conceal obstacles. An invading army must survive all of it while being shot at. In 1941, the U.S. Army and Navy faced a terrifying realization. They did not possess the machines needed to land an army. Traditional troop transports were too large to approach shore. Small boats could not carry vehicles. Existing landing craft were slow, fragile, and poorly designed. There were no standardized vehicles for tank landings, artillery deployment, mass infantry disembarkation, rapid unloading of supplies. Every problem pointed to the same conclusion: the invasion would fail before it began. Axis planners understood this weakness. German coastal defenses were built on the assumption that any landing force would be vulnerable, slow, and disorganized. Japan fortified islands, believing that attackers would be exhausted before reaching shore. They were right based on existing technology. What they did not anticipate was American engineering. In the United States, something unprecedented happened. The military stopped asking, "How do we fight this battle?" and started asking, "How do we build the tools to fight it?" Scientists, civilian engineers, shipbuilders, industrial planners, they were pulled into the war effort. Factories became laboratories. Shipyards became test sites. Failure became data. The invasion problem was no longer tactical. It was scientific. To invade a beach, planners realized they needed to master variables that armies had never controlled before. Oceanography, meteorology, soil mechanics, structural engineering, hydrodynamics. Beaches were mapped. Sand was tested. Tides were calculated to the minute. What had once been guesswork became math. At the same time, military doctrine changed. Army and Navy commands learned to cooperate, not compete. Joint planning became mandatory. Every landing would require naval gunfire, air superiority, engineering units, logistics planners, medical evacuation systems. Amphibious assault became a system, not a single event. The first American amphibious landings were messy. North Africa exposed coordination problems. Early Pacific landings revealed design flaws. Boats sank. Vehicles drowned. Men died. But unlike past failures, these were studied, not ignored. Every mistake led to redesign. Every disaster led to improvement. By 1942, time was running out. Germany strengthened the Atlantic Wall. Japan fortified island chains. Every month of delay made invasion deadlier. The United States had to solve the impossible fast. And the solution would not come from generals alone. It would come from machines. Some of those machines were crude. Some were ugly. Some looked like they had no place in modern warfare. But they would become the most important weapons of the war. Not because they killed the enemy, but because they delivered the army to the battlefield. In Part 2, we follow the machines that made invasion possible. The boats, the vehicles, and the designs that turned water into a road. Before an army could fight, it had to arrive. And in World War II, arrival was the most dangerous moment of all. Between ship and shore existed a narrow strip of water where men were exposed, machines failed, and plans collapsed. This zone, neither sea nor land, became the focus of one of the greatest engineering efforts in military history. If America could not master this space, no invasion would ever succeed. The most important invasion weapon of the war was not a rifle, a tank, or an aircraft. It was a boat small enough to approach shore, strong enough to survive waves, and simple enough to be mass-produced by the thousands. Before the war, no such vessel existed. Navies built ships. Armies built vehicles. Landing craft belonged to neither world, and that is why they had been neglected. The breakthrough did not come from a military laboratory. It came from a civilian boat builder in New Orleans. Andrew Jackson Higgins specialized in shallow draft workboats designed to navigate swamps and bayous. His designs were blunt, flat-bottomed, and unfashionable, but they could run aground without breaking apart. This mattered. Military planners brought Higgins a simple problem. How do we land men directly onto a beach? Traditional boats forced soldiers to climb over the sides slow, exposed, deadly. Higgins' answer was radical in its simplicity. Cut the front open. The Higgins boat, officially the LCVP, featured a reinforced bow ramp that dropped forward, allowing troops to run straight onto the beach. No climbing, no delay, no bottleneck. It carried 36 fully equipped soldiers or a jeep and crew. Its shallow draft allowed it to reach beaches other boats could not. It was ugly. It was loud. It was perfect. Factories across America began mass-producing them. By 1944, more than 20,000 Higgins boats were in service. Without them, there is no Normandy landing. Dwight Eisenhower later admitted that without Higgins' design, the war in Europe could not have been won. But the Higgins boat had limits. It was unarmored. It could not cross reefs. It struggled in heavy surf. And it could not carry heavy armor. In Europe, beaches were sandy and sloped. In the Pacific, they were not. The Pacific War exposed a different reality. Japanese-held islands were ringed with coral reefs that stopped conventional landing craft hundreds of yards offshore. This forced troops to wade through open water under fire, a death sentence. Naval planners needed a vehicle that could swim, crawl over reefs, drive onto beaches, carry men and supplies. Nothing like it existed. So America built one. The solution came from a civilian rescue vehicle, originally designed for Florida swamps. Engineers modified it, armored it lightly, and armed it. The result was the LVT landing vehicle, tracked. It looked like a box on tank tracks. It was slow. It was vulnerable. It was indispensable. LVTs carried Marines over reefs at Tarawa, Saipan, and Iwo Jima, places where traditional boats failed catastrophically. At Tarawa, early landings without LVTs ended in slaughter. Later waves using tracked vehicles survived. The lesson was immediate and brutal. Technology decided survival. As the war progressed, LVTs evolved. They mounted machine guns, then cannons, then heavier armor. They became both transport and fire support, the first vehicles to reach the beach, absorbing enemy fire meant for infantry. They were not elegant. They were effective. Another problem remained unsolved. Tanks. Heavy armor was essential once ashore, but landing tanks meant cranes, delays, and exposure. Engineers developed an audacious solution. Make tanks float. Using collapsible flotation screens and propellers, standard Sherman tanks were modified to swim ashore. They were launched miles from the beach and driven through surf under fire. At Normandy, DD tanks saved lives where they arrived and drowned where conditions overwhelmed them. The concept was risky. The execution was imperfect. But when it worked, it shattered German defenses. To support these machines, entire families of landing craft were created. LCTs for tanks, LCMs for vehicles, LCIs for infantry, LSDs, massive ships that could beach themselves and unload directly. The LSD became the logistical backbone of invasion warfare. It carried tanks, trucks, fuel, and men, then reversed off the beach and returned for more. No navy had ever built ships meant to run aground on purpose. America did. The true American advantage was not design alone. It was production. Landing craft were built in inland factories, shipped by rail, and assembled rapidly. Losses were expected. Replacement was guaranteed. Invasion became sustainable. These machines did not eliminate danger. Landing craft burned. Vehicles sank. Men drowned under the weight of gear. But each improvement reduced casualties. Each redesign bought time. And time saved lives. By 1943, America could land an army. But landing was only the beginning. Once ashore, engineers faced a new nightmare. Beaches that swallowed tanks. Mines buried beneath sand. obstacles designed to tear vehicles apart. To survive, invasion would require science, not just machines. In Part 3, we enter the world of engineers, physicists, and specialists who transformed beaches into battlefields that could be crossed. Landing an army was no longer the impossible task. By 1943, American forces could reach hostile shores in strength. But reaching the beach did not mean surviving it. The shoreline itself had become a weapon. Every yard of sand, every tide, every buried obstacle was designed to stop momentum. And if momentum died, the invasion died with it. To invading forces, a beach looked simple. To engineers, it was a nightmare. Beaches shift constantly. Sand compacts differently under weight. Tides expose dangers only at certain hours. Water depth changes by the minute. A tank could roll across one stretch and vanish in the next. Understanding this environment became a matter of life and death. Early invasions relied on rough maps and outdated charts. They failed. In response, Allied planners began treating beaches like engineering projects. Special reconnaissance units collected sand samples under fire. Divers mapped underwater obstacles at night. Aerial photography revealed patterns invisible from the ground. At Normandy, Allied intelligence knew where obstacles were placed, how tides would expose them, which sectors could support armor. This information saved lives before the first shot was fired. One of the least glamorous sciences of the war became one of the most important. Soil mechanics. Engineers studied how much weight sand could support. Too dry, tanks bogged down. Too wet, vehicles sank. Wrong-angled tracks lost traction. These calculations determined where tanks landed and when. At Omaha Beach, unexpected sand conditions contributed to chaos. Elsewhere, correct predictions allowed armored breakthroughs. Science decided success. German engineers understood the problem too. They filled beaches with wooden stakes tipped with mines, steel hedgehogs, Belgian gates, buried explosives. Placed correctly, these obstacles destroyed landing craft and tanks before troops could deploy. They were designed to work with tides, invisible at high water, lethal at low. Removing them under fire required something new. The answer came from an unconventional source, British Major General Percy Hobart. Hobart believed that specialized machines, not standard tanks, were needed for invasion. His units developed bizarre-looking armored vehicles that soldiers nicknamed Hobart's Funnies. They were mocked during training. They were indispensable in combat. One version mounted rotating flails that detonated mines ahead of advancing troops. The machines were terrifying to watch, chains spinning violently, explosions erupting beneath them. They cleared safe lanes where infantry could follow. Without them, entire battalions would have been wiped out. Other vehicles laid bridges across trenches and obstacles. Some carried fascines, bundles of logs, dropped into ditches to create instant roads. Others mounted dozer blades, reshaping terrain under fire. The beach was no longer fixed. It could be engineered in real time. Concrete bunkers dominated invasion beaches. Small arms fire was useless against them. Flamethrower tanks projected fire into embrasures, forcing defenders out or suffocating them inside. The psychological impact was immense. Bunkers that could stop infantry were neutralized by machines. Supporting fire required precision. Naval guns fired from miles offshore, their accuracy dependent on calculations involving wind, Earth's curvature, ship movement, projectile ballistics. Spotters coordinated with engineers ashore. Mistakes killed friendly troops. Correct fire broke defenses. The invasion was as much calculation as courage. Aircraft added another layer. Bombers attempted to destroy defenses before landings. Fighters strafed beach positions. But bombing accuracy was imperfect. Many fortifications survived, which meant ground engineering still mattered. Machines had to work even when air power failed. Not all engineering was mechanical. Combat engineers, men with explosives and wire cutters, cleared obstacles by hand. They worked in shallow water under machine gun fire. Casualties were extreme. Their survival depended on machines absorbing the first blows. At Omaha Beach, many engineering solutions broke down. Current scattered landing craft. Bombing missed targets. DD tanks sank. Obstacle-clearing teams were destroyed. The result was near disaster. Elsewhere where science and machines functioned as planned, beaches fell quickly. The contrast was stark. Preparation saved lives. Every landing became a lesson. Designs were adjusted. Procedures rewritten. Equipment improved. By late 1944, invasions were smoother, faster, deadlier. The beach was no longer an unknown. It was a controlled environment. But one problem remained unsolved. Landing forces was meaningless if they could not be supplied. Ports would be destroyed. Harbors unavailable. The invasion could stall within days. To win, the Allies would have to do something no army had ever done before. Bring the port with them. In Part 4, we explore the floating harbors, logistics, and supply systems that kept invasion armies alive. Taking the beach was only the beginning. History was filled with victorious landings that ended in defeat, not because the enemy counterattacked, but because the invading army ran out of everything that kept it alive. Food, fuel, ammunition, replacement troops, medical supplies. An army without supply is not an army. It is a crowd waiting to be destroyed. Modern armies depend on ports. Ships unload cargo efficiently only where cranes, docks, and infrastructure exist. The Allies knew that every major port in Europe was fortified and rigged for demolition. If they waited to capture one intact, the invasion would stall. Time favored the defender. So Allied planners faced an unprecedented question. How do you supply an army without a port? The answer sounded impossible. Build a port. Not on land. On the sea. British and American engineers proposed constructing artificial harbors that could be towed across the English Channel and assembled off the invasion beaches. The idea was risky, expensive, and untested. But without it, Operation Overlord might fail within weeks. The artificial ports were codenamed Mulberry. They were not single structures, but entire systems. Massive concrete breakwaters, floating roadways, pier heads, anchored docks. Each piece was prefabricated in Britain, then towed to Normandy after D-Day. The scale was staggering. Some concrete caissons weighed more than 6,000 tons. The sea does not tolerate mistakes. Engineers had to design structures that could withstand tides and storms, support heavy vehicle traffic, be assembled quickly under threat of attack. No existing engineering manual addressed these challenges. Every calculation was experimental. Failure would mean starvation at the front. Within hours of the landings, engineers began assembling the harbors. Under fire, under air attack, under constant pressure. Floating roadways connected ships to shore. Trucks rolled across the sea. The invasion had brought its own infrastructure. For the first time in history, an army arrived fully supplied. Then the weather intervened. On June 19, 1944, One of the worst storms in decades slammed the Normandy coast. Waves shattered floating structures. Anchors dragged. Roadways collapsed. One Mulberry Harbor was destroyed completely. The other survived barely. Its survival kept the invasion alive. Beyond the harbors, logistics became a mathematical operation. Every soldier required a daily tonnage of supply. Fuel consumption was calculated to the hour. Ammunition usage predicted by battlefield data. Nothing was left to chance. This was warfare run by spreadsheets, long before computers existed. Fuel posed another challenge. Transporting gasoline by tanker was slow and dangerous. The solution was another engineering gamble. Undersea pipelines. The project, codenamed Pluto, pipeline under the ocean, laid fuel lines from England to France beneath the channel. Once operational, it delivered millions of gallons directly to advancing armies. Fuel no longer arrived by ship. It flowed invisibly. Logistics included the wounded. Hospital ships, mobile surgical units, and evacuation plans were integrated into invasion doctrine. Casualties were moved off beaches within hours. Survival rates increased dramatically. Medicine became another battlefield science. In the Pacific, distances were greater. Ports were smaller or non-existent. Here, logistics relied on floating bases, repair ships, and continuous resupply from the United States. Entire islands became staging grounds. Victory depended not on bravery alone, but on shipping schedules. By late 1944, Allied logistics outmatched the Axis completely. American factories produced faster than Germany could destroy. Ships arrived faster than Japan could sink them. The invasion was no longer fragile. It was inevitable. The machines had landed the armies. Science had mastered the beaches. Logistics had sustained the advance. What remained was the legacy. In the final part, we examine how amphibious warfare was transformed forever, and how the science born in World War II still shapes modern war. By the end of 1944, the impossible had become routine. American forces no longer asked whether a beach could be taken. They asked when. The transformation was not accidental. It was engineered. World War II had turned amphibious warfare from a desperate gamble into a repeatable process, one built on science, machines, and logistics working as a single system. Before the war, invasion meant improvisation. After the war, it meant doctrine. Every successful landing fed into a growing body of knowledge. How beaches behave under armor. How tides affect movement. How supply flows determine victory. How machines must be designed for failure, not perfection. The U.S. military institutionalized these lessons. What had been learned in blood became policy. The U.S. Marine Corps emerged transformed. No longer a small expeditionary force, it became a specialized assault arm trained to strike from sea to land. New training centers were established. New equipment standards enforced. Joint operations became mandatory. The separation between Navy and Army blurred. War became integrated. The machines of WWII did more than support soldiers. They changed the relationship between man and environment. Beaches were no longer barriers. Oceans were no longer shields. Distance was no longer protection. This concept shaped post-war strategy. Power could now be projected anywhere on Earth. The lessons of amphibious warfare carried directly into the Cold War. Korea saw rapid landings at Incheon, executed with confidence born from WWII science. Vietnam relied on riverine and coastal operations, refined decades earlier. Even modern rapid deployment forces trace their lineage to Higgins boats and LSDs. The machines evolved. The principles remained. Amid technology and logistics, the human cost must not be forgotten. Machines failed. Plans collapsed. Men drowned within sight of land. Every improvement came at a price. Engineering did not remove fear, it reduced helplessness. And in war, that difference is everything. Had America failed to master amphibious warfare, the war could have lasted years longer. Europe might have remained divided differently. The Pacific War might have required unimaginable losses. The science behind the landings shortened the war and reshaped the world that followed. By 1945, invasion was no longer a gamble against nature. It was a confrontation with the enemy, on terms chosen by the attacker. The sea had been conquered not by ships alone, but by understanding. Empires once relied on oceans to protect them. World War II ended that illusion. Through science, engineering, and relentless adaptation, America learned to cross any sea, breach any shore, and sustain any army. The machines that carried men onto hostile beaches did more than win battles. They rewrote the rules of war. And in doing so, they turned the impossible into procedure.